Utah. Today I'm very happy to introduce my lab, which is the multi-scale energy transport, conversion, and storage lab, can call MEX lab. So I will briefly talk about what problems we solve and what we do. I will only focus on the high-level introduction, so I will not go to very detailed results or whatever. So let me start from some examples. We know that many companies like Boeing is developing the next generation hypersonic vehicles. However, one of the most challenging problem they are facing is a huge thermal load, because the surface temperature can reach as high as 1500 degrees Celsius. Not only for the hypersonic vehicles, but also for re-entry vehicles developed by NASA and SpaceX and other companies. They want to improve the reliability of the re-entry vehicles, so the surface protection is very important. Also, U.S. Department of Energy is developing the advanced turbine systems, and they want to push the temperature to as high as 1700 degrees Celsius. So that's very high temperature. So our research is to look into the thermal transport at so high temperatures, which has not been done before. And we are developing new coating materials which can sustain so high temperature. And the research is spread from atomic scale to material level, and even finally to a lab scale and to our human scale. Not only for energy transport, but also for energy conversion systems like nuclear power plant or thermal plant, or even thermoelectric energy converter. So all of these applications require high temperatures to improve the efficiency. So as you can see in this, for example, the next generation nuclear power plant developed by Department of Energy. So they want to increase the efficiency. If you remember from thermodynamics, the higher temperature, the higher efficiency we can reach. So in this case, we care about energy conversion. And after conversion, we need to store the energy, that is a battery. So we are also studying batteries. Not only for the large scale applications, but also to the micro and the nano scales. For example, as we are pushing the performance of the personal electronics like laptops, cell phones, we want to add more and more transistors per unit area. So that will give a lot of joule heat. So how to manage this joule heat at nanoscale? That has been a problem for 20 years. And recently, we are also facing a new problem like in power electronics used in wireless charging and radar systems. So we also want to push the limits of the charging speed and the detection distance of radar. And in all of these cases, we want to study the multi-scale thermal transport problems from atomic scale to human scale. And also it involves multi-physics, including electrical transport, thermal transport, and ionic transport. And another important area we are studying is thermal insulation. As we know, buildings consume 40% of the total energy used in the United States, which is about $400 billion per year. And we want to develop ultra low thermal conductivity materials for thermal insulation to save energy. Not only for buildings, but also for pipelines and even for vaccine storage. We really need very high performance insulation. So the methods we use to study these problems range from atomic scale simulations like molecular dynamics, first principles, and to numerical studies at large scale like machine learning and finite element simulations. We are also doing the state-of-the-art experiment to characterize the thermal conductivity and the optical properties at a very high temperature. This is a brief summary of what I just showed. Our lab essentially is to use predictive methods based on multi-scale transport simulations, plus experiment to push the boundaries of cutting-edge technologies for energy applications. So this is our lab information. You can search my name by Google, and you can find all the information, my email, my lab homepage. And because the problem we study spread from physics to chemistry to mechanical engineering, and so it is a multi-disciplinary research. So we publish really a very broad very broad scope of journal publications, as you can see from Nature, Science, Nano Letters, Nano Energy, Advanced Materials, and so on. So if you're interested in my lab, just feel free to contact me through this email. Yeah, that's it for me. Any questions? So can you still hear me?
Yeah, we can hear you.
If there's no question, I will step back.
Tianli, there's a question in chat asking what qualifications you're looking for in students to join your research lab in the future.
Yeah, I saw it. Yeah, if you have background in heat transfer, I mean, any graduate, if you have a bachelor degree in mechanical engineering, physics, chemistry, and material science, that would be good. Okay, I think that's it. I will hand it over to, yeah.